Okay, so I wanted to go over the quiz that we had the other day, and question 1. So the question 1 says, a solution is prepared by dissolving 25 grams of sodium chloride, and then they give you the molar mass, and then 75 grams of water. And then they said, what is the mole fraction of NaCl? So mole fraction requires you to figure out the moles. And moles is kind of easy, right? You have how many grams, and then you divide by the molar mass, which would be, so I didn't annotate it, that's my fault. But I should have written how many grams per mole. And so if you look here, the first thing I did was I took the moles of NaCl, and I figured out, they gave us 25, and NaCl is 58, so I divided those two, and I got how many moles. And then I figured out how many moles of H2O I have, and I took the 75, and I divided it by 18, and I got 4.16 moles, and then I just compare those two, like what is the mole fraction of NaCl in the solution. So when they say just mole fraction, I would compare these two numbers. But because it's saying in the solution, we take this, which is what we're looking for, NaCl, which is 4.27, but in the solution, there's both of them. So we put that, and so we divide those two things. So when I say that, I mean you add both of them together, and that is the fraction that is, and the closest to 0.093 was a D, 0.1. For the next question, it asks, how many carbon atoms are in 11 grams of CO2? And so what I did was I figure out how many moles of CO2 I have. So if I have 11 grams, right, I put 11, that should say grams, 11 grams over 44 grams per mole. And so the grams and the grams would cancel out, and you would just get moles. You would get 0.249 moles. And then, since we're figuring out how many atoms, 1 mole has Avogadro's number, right? 6.02 times 10 to the 23rd. We multiply that. We have 0.249 moles. Let me focus this. And we multiply that by, one more time, Avogadro's number, and we get 1.505, and the closest to that is A. I don't know what's going on with the focus with this thing. Okay, next problem. It says element X has 2 isotopes. Now, a lot of people got these questions, right? So you're basically just, it's like calculating your grades. You take the 20% and you move it 2 decimal places over, as you see that I've done here, and you get 0.2, and then you multiply that by the mass, which was 10, you get 2. And the next one is 80% of the isotope yield, which is 0.8. You multiply that by 11, and you get 8.8. You add those two together, you get 10.8 AMU, and that's C. The next question is magnesium isotopes have the following abundance. It's the same thing. So this time you get 24, magnesium 24, 25, and 26, which if you look here, one second. If you look here, I have 24, 25, and 26. And then you just multiply. You did the same thing that I did up here. You move the decimal places 2 places over. You take here and you move it 2 places over, and you get 0.789. Now, just for the sake, it's going to give me close enough numbers if I put another 9 here or not. So I just put 0.789. And then I took 10%. I moved the decimal places 2 places over, and I got 0.1. And then I took 11.01%, and I moved the decimal place 2 places over, and I got 0.01. And then I multiplied it by the according mass, and then I added them all up, and I got 24.2 AMU. Okay, now for the questions in the back. This question, now you got to read the question, right? Because the questions can throw you off. So for this question, it says a compound has 40% sulfur and 60% oxygen by mass. What is the empirical formula? When they want the empirical formula, they want it in the smallest ratio possible. So when we do that, we take the 40% of silver and we divide it by its grams per mole, or its molarity, and you get 40 grams, or 40% divided by, oh no, what you do is you pretend those percents, here we go, you pretend that percent is grams. So you imagine you're working with 100 grams. And so that way you have, if it's 40% and 60%, you say you have 40 grams. And so it's like 40 grams over 32 grams per mole, because sulfur's mass is 32. And so you divide 40 by 32 and you get 1.247. And then you do the same thing. That 60%, you imagine again that you're working with 100 grams, and 60% of 100 grams is 60 grams. And you take 60 grams and you divide it by 16. Why 16? Because the mass of one atom of oxygen is 16 grams per mole. And you take that and you divide those two and you get 3.75. Now you're looking for the empirical formula, so you need to find the ratio. And so then you take the smallest number, you automatically make it 1. And then you look at the next number, 3.75, and you divide it by this so you can figure out the ratio. So 3.75 divided by 1.2 is approximately 3. So there's approximately a 1 to 3 ratio. So the 1 would be the S, which is why I put just S by itself. And then the oxygen would have a ratio of 3. So it's SO3, so the right answer was D. Okay, next question. It says a compound is 52.2% carbon, 13% hydrogen, and 34.8% oxygen. Now what is it? Again, this time it asks you for your empirical formula. Remember, the empirical formula is in its smallest and lowest common denominators, right? It's the smallest numbers possible. So again, we had the same thing we did up here. We assume that the number here would be 100 grams. And so 52.2 grams of carbon, 13 grams of hydrogen, and 34 grams of oxygen. And so we take that and we divide them by their molar masses. Carbon has a molar mass of 12, hydrogen has a molar mass of 1, and oxygen has a molar mass of 16. And that way you cross out the grams for each and you get the moles. Then you find the ratio. So this question, what did they ask for again? They asked for the empirical formula again. We talked about that. And so this ratio, the smallest number is 2.175. That's 1. And then 4.3, it's about double 2.17, right? So I just put 2. And then I actually divided 13 by 2. And then that's about 6. And so you would get 2 to 6 to 1 ratio of carbon, hydrogen, and oxygen, and that's what you would get, and that is answer choice B. Next question asks you for the mole ratio. So this time it's less work. You just have to figure out the ratio. So you do the same thing. You take the grams and you divide it by the molar mass, and you get a 2 to 1 ratio. You take 6 grams and divide it by 58.4, and you take 4 grams and you divide it by 74.5, and these are the two numbers that you get, and the smaller number is 0.05. You assign that 1, and you get 0.1, and if you divide 0.1 divided by 0.05, you get 2. So that's a 2 to 1 ratio. So that's C. Last question everybody got wrong, I think, because I think people didn't read the question right. And so if you look at the last question, it asks for the molecular formula. So there's an extra step here. So we do the same thing as we always do. They gave us 40% carbon. So we imagine that we're working with 40 grams of carbon, 6.7 grams of hydrogen, and 53 grams of oxygen. We divide them by the molarity, which is the grams per mole. So that's 40 divided by 12 for carbon, 6.7 divided by 1 for hydrogen, and 53.3 divided by 16 for oxygen. So we get 3.3, 6.6, and 3.3. So 3.3 both times is a smaller number, so that ratio automatically gets, it's the smallest number, so it gets automatically assigned 1. And 6.6 is double 3.3, so it's a 1 to 2 to 1 ratio. Now, that means a lot of people probably put answer choice A. But what you didn't read was what is the molecular formula. So if we have 60 grams of it, and if you add up carbon, hydrogen, and oxygen, you get 30 grams because it's oxygen is 16 grams, carbon is 6, and hydrogen is 1, and that gives you 30 grams. And then you divide the two, because the empirical mass here, hydrogen is 2, so if you add 6 plus 2 plus oxygen is 16, you get 2, and then you double all of them, and so the correct answer is B.